All right, we're looking at some Unit 5 content right now, and what we're going to start focusing on is another aspect of data analytics, and that is, how really is data analytics viewed, and what is it used for, and are there different types and different levels? And the answer to that is yes, there are different types and different levels of data analytics, and we can think of it in a lot of different ways, and a lot of it is sometimes relevant to your role within an organization and what the motives of that organization are. But data analytics can be used in many different ways to analyze what's happened, to make predictions about what might happen, and in more powerful cases, steer the ship in some cases so that the best things happen. And that's really kind of what the ultimate goal of it all is, in my mind, at least philosophically. I have, kind of the topics listed here at the top of the unit folder. We're going to talk about the difference between what we call prescriptive and predictive analysis through a couple of postings I have here. Then we're going to jump to pivot tables and this other tool called Solver. But this video here will focus more on the analytics pieces and the materials related to that. And so the first thing I'm going to do is take us out to this article that we have linked up from Oracle Corporation, talking about what they view as the 4 types of data analytics. So I'm just going to kind of bring this up, and I know you guys can read this on your own. But there's different categories, and a lot of what we assume data analytics is for is to analyze, in some cases, what has happened. So in other words, like if you go to the doctor and you get tests run, that brings us to what we call diagnostic data analysis. Let's say you get like an MRI and you can see the output of it, or they run a bunch of numbers on you and you can look at those and run a report, and then you can say, hey, your cholesterol is at this level, your blood sugar is here, you're going to die if you keep eating like this. And that falls into the diagnostic realm, where we're kind of looking at what's happened. In some cases, we're also kind of looking at what we call descriptive data analysis. So we're describing the real world, typically in some way, by looking at a set of data, and we're using it not necessarily to diagnose, like in a health situation, but we're looking at it more in the way of like just qualifying or classifying information that we have, so we have a better understanding of the world around us. But then we get to these other 2 levels, which are, I would say, the higher levels of data analytics, and what we really think of when we think of data analytics. At least, our management, I think, largely thinks of it this way. We have first what we call predictive analytics, and as it indicates here, it's probably the most common form or category of data analytics. Because normally we're trying to look at data to identify trends. What happen? Like if you do one thing, what's going to happen? So like if you drive too fast in icy conditions, it's pretty safe to predict that you're probably going to wipe out. Because it's slick. And in some cases, it also extends to what we call causation. And it's kind of interesting because, some of it is just kind of dictated. We keep collecting data and it clearly is moving this direction, and you can kind of see the direction, especially if you plot it graphically. And then using some statistical stuff, basically like, how certain we are of like data falling within a range, we can do what we call predictive and statistical modeling. So we can say that maybe in the future we can predict, if we keep, like if you look at the whole global climate change thing, right? If people are saying if we continue producing this much carbon, temperatures are going to go up this much, oceans are going to go up this much, and all these people will be out of their homes, that kind of thing. And that's kind of an interesting field, and we do this a lot in data analytics, and most likely your career path will probably be related to this primary area of it. There is a higher level, though, and that one is what we call prescriptive data analytics, where we kind of leverage higher level tools altogether, but we also deal with stuff in a different way. In other words, we look at the data that we have, but we also make assumptions about situations, and often we create what we call mathematical models to represent situations that might be right, and then using those models find ways to optimize what we're doing. And you hear these like words I'm throwing around, like optimization and random testing and whatever. But prescriptive data analytics goes into this higher realm of where we can, maybe dictate a good course of action in order to get a good result based on the mathematical models that we build.
If I'm not
Um,
mistaken, that was one of the higher parts of that graph that you showed us, right?
yes, absolutely. And in fact, Anthony, that's exactly where I'm going back to next. And, I have these two graphics here. And if you guys remember, I showed you this one. This one came actually from one of our internal data scientists here at Gateway. He used this in a presentation and he borrowed it from somewhere. And I don't know where it came from, but the whole point of data analytics ultimately, like if you're doing the real high levels of it, falls into this area. So prescriptive and process optimization, these are the real high-end philosophical things that data scientists work on, because really what we want to do, right, is you know prescribe, let's say, to planet Earth not to use so much carbon or whatever, produce pollution to heat up the climate, and then warm up the planet and flood the oceans or whatever. Um, and they probably have some models, very sophisticated ones that determine this and predict it. But then using those same models, you can also alter some stuff. And I'm sure the one thing they didn't predict at all, was the fact that, hey, we're going to have this pandemic and nobody's driving to work anymore. So all of a sudden we're not polluting. And I think that's pretty astounding that like it takes something like people like getting sick and potentially dying to all of a sudden snap us into like a more green approach to living. Pretty bizarre, right? Who would have predicted that, though? The predictive models would have shown that these people are going to keep driving, to work. We're going to keep, spewing out pollution, and it's inevitable that we're going to mess up our climate, right? That kind of thing. And that you would look at from what's happened already, and you can predict where the numbers are going. The prescriptive takes it to a higher level, and this is not a level that we get to, by the way, in this program. It is really more master's level type work. Although we touch upon some of the concepts, and actually working with a tool like Solver, which is one of the topics for this chapter, is one of those tools that's used for process optimization and prescriptive analysis. But a lot of that, you notice the word models in the mix here. Models refers to mathematical models. And so when we're working with these higher levels, we're also assuming that we can take some sort of a real world situation and transform it into an equation that accurately represents the real world. Now, that sounds easy, right? Einstein managed to do like E equals MC squared, and that's like, this grand equation of the universe somehow. But it's ridiculously simple at the same time. Uh, you know, so how do you know that you're coming up with a model that's correct? Well, you have to look at the situation and then make mathematical determinations. And different situations will require different types of math. So, for example, if I'm predicting like sales figures, that's a fairly simplistic type of calculation. If I'm trying to predict global weather, well, you can imagine how much more complicated those formulas are. They're significantly complex. And anytime you're adding like mathematical complexity, you're also increasing the amount of variance in the output, which makes it less certain, at the same time. So the one thing that a data scientist will strive to do is to create mathematical models that accurately represent the real world. And I think that's a really important thing. Where we will operate is more on these bottom levels, moving up through and to the predictive level and brushing upon that level. So we will do some of that. When you guys move on to your bachelor's or master's degree and stick with this topic, you will move into those higher levels and get deep into them. All right,
So that was my other question: is how far are we going for data analytics?
well, in my mind, we are going solidly through the predictive model area. So we get up to this point, but as data analysts, it's not necessarily our job to predict. Anthony, to
Okay,
answer your question. That goes down to other positions typically.
got you.
It's not that you guys wouldn't be able to, and so let's make that distinction. I think that that's a good question, because I could certainly look at the data, and we were doing this in previous semesters, and we will do it in this semester too, where we're looking at live COVID data, and you watch the news, and they have all these stories, and everybody presents it in different ways, but they're really pulling the data from the same location, right? But if you take the data for yourself and plot it and look at it and spot the trends, and it wasn't really difficult to spot the trend, for example, that uh, last semester when we were like kind of halfway through the semester towards the tail end, getting into November, basically in December, we're like, these numbers aren't going down. It looks like they're accelerating. That's what we were noticing just by looking at them. And sure enough, they kept climbing. And it's just now that, and I think it might be the vaccine part of it, or maybe it's just cold and people aren't going anywhere, whatever it is. The numbers are starting to flatten out a little bit, and infection rates and death rates are starting to level off. So it'll be really interesting to look at those and see if we can spot a trend in that now. And yeah, it's not our jobs to really be prediction people, but sometimes the data is just screams it, obviously. And when you get up to the modeling thing, it's really where it crosses over. The mathematical modeling is kind of like the next challenge in the ladder. After an associate's degree, in order to study these fields, you will have to take classes like calculus and high-level trig and discrete mathematics and linear algebra and all these like fields of math you've never even heard of, in order to be able to accurately create mathematical models that can be used for the higher levels. But it's a process.
Thank you.
It doesn't happen all at once. But Anthony, I think it's an excellent question. Now, a lot of what we do is gather the data. And I love the chart. Oh my God, we have a lot of data. Data fortress, data is stored, secured, and available. So it's kind of like just putting it in a database in our spreadsheet, and you can look at it, right? And a lot of companies get to that level pretty quickly. Then you get up to what we call basic reporting, which is really just kind of a way of like maybe getting the stuff into a spreadsheet, maybe creating a simple chart or graph, maybe, or just summarizing numbers or doing counts or classifying the information. Get up to the business intelligence level, and that's where we start to really dig much more into the I'm not going to say statistical analysis of it, but the visualization of the data often happens at this level. So like if I plot sales, and let's say this is my sales line, and I see it's just going up, I'm like, hey, looks good. Let's go on vacation. I'll have the money. Sales are going up. And so that happens here, but really kind of taking the data and converting it into something that helps people in positions of power make decisions on which way to go is really important. That's, I look at that piece, like when I do scheduling, for our department, for IT. We're going into fall semester, we were very uncertain. We were coming in, and our enrollment rates were tracking about 25% down from the previous year. That's huge dip. A percentage point or two, hey, that's normal fluctuation. Double digits going like 25% down, that's huge. But so I had to be really careful about who I was assigning what to and how many adjuncts I hired. I decided preemptively not to hire any adjunct instructors, thinking that if our numbers are this far down, I'll be lucky to keep my full-time people working full-time, right? And I was just doing that off of very basic numbers that I was receiving. But that reporting was enough for me to make a decision, to make a choice. And of course, I didn't make that choice alone. I made it with my dean. But if you start to take it even to a higher level than just like looking at the data and in a visual format, typically, that is more meaningful than just basic reporting. Then you get into the statistical analysis of it and looking at that data. And as you guys have probably learned in stats class, or if maybe you're taking that right now, you will learn that there's confidence intervals, or, if you have a trend line, that there's a range around that trend line that you can be fairly certain within a 95 percentile that future data will fall in that range. And then you really can only determine that through statistics. So the math aspect comes into it pretty heavily. And that's one of the reasons why statistics is included in this program, because you need to understand those concepts, because the people that you are going to provide this business intelligence to do understand those. I mean, that's why, managers get bachelor's degrees in business and MBAs in business, because they study stats and they understand what those things mean. Stats can also be used, positively or negatively. We always like to think it's impartial, but you can skew your data as well, and that's a whole topic area there too. So this is just really, folks, a precursor to kind of the field, as we're kind of peppering in these topics as we move through our degree program, and as we get into deeper levels, they become a natural part of the conversation. But we want to kind of prepare you, put it on basically your horizon, so you see what's coming down the road. And so we're kind of like building through these areas right now, and unfortunately, we're still kind of down here right now. And we're okay. Well, hey, we got a bunch of data. What are we doing with it? Oh, okay, we're kind of filtering it and sorting it. This is kind of where we're at right now. And even when we start to bring Python into the mix, a lot of it will be still at this level, slightly crossing over into this range. And then as you get into the subsequent courses, we keep building up. There's always a little bit of backtracking, but there's always a forward momentum as well. The other little graphic that I threw in here, and this is one that Christopher had, and I liked it because I liked what it said here. But these are, basically based on, the bullets that came from that article that we looked at, and summarizing it in single phrases. All right, folks, that will end this little lecture bit, and we are going to move into other materials now.